of yesterday made into modern highways of today. Adventure and mystery around the corner. As we travel smoothly and swiftly along these broad highways, how many of us think of the work that goes into their construction? Highway departments plan far ahead the most efficient highway system, and always, as science learns better methods, the roads are improved. Engineers prepare the plans and specifications. These are usually submitted to different contractors, and the lowest reliable bidder gets the contract. 500 workmen of many different crafts will be employed at one time. This contractor confers with his foreman on the blueprints. Work begins. Surveyors stake out the ground for the direction and height of the road. Their instruments measure the distance exactly. These stakes guide the carpenters in building their forms and the graders in laying out the proper levels. A small brass point or plumb bob held from a string is used to show the line which will be marked by stakes. Danger, slow, equipment at work. Mountains are no barrier to the highway engineer. Cuts are made in mountains and hills in order to make the road straight. Slopes are graded to proper levels to prevent landslides. It is dangerous for the men working high up on the mountain cliffs preparing to dynamite a mountain, but these men are experts at their work. Jim is preparing to lower himself down the cliff by a rope. He drives the iron stake securely into the ground. His life depends on its strength. A firm knot tied to his safety belt holds him fast. Cautiously selecting his footholds, he lets himself down the cliff to a lower ledge. There he joins the other dynamiters at work. Each man is tied by a rope. Heavy drills called air hammers cut the holes to the proper depth. The power is furnished by an air compressor, which is run by a gasoline engine. The air is forced through hoses to operate the heavy, unwieldy drills. These holes are drilled 4 to 6 feet apart. The powder expert judges the proper depth and spacing of the holes, and also the amount of powder that this particular rock will take. 2 men are necessary to operate the long-stemmed drill hammer. Dirt is blown out of the holes by the compressed air. Powdered dynamite is put in first. Then a stick of dynamite is prepared and cut so that it will spread in the hole. This stick has an electric cap and wire to carry the spark which will blow up the dynamite. The hole is filled up with sand or loose dirt. More sticks will be planted in other holes until they have the number necessary to blow up this ledge. A main wire leads from the generator box that will set off the electric spark. The wires from the different holes will be tested and joined to this main wire. The main wire must stretch far enough away from the blast so that the man who fires the shot will be safe. Traffic passing near must be stopped and kept a safe distance away. There goes the warning signal. Another blast is ready. Yes, the dynamiters have done a good job. The loose rock can now be moved by a huge power shovel. Trucks will carry the dirt to low places that need to be filled in. It takes only a few shovelfuls to fill up the truck, and then off she goes. soon as one truck leaves, another pulls up for a load. These are well timed so that no time is wasted. Some shovels are able to scoop up 5 cubic yards of dirt. The operator oils his boom shovel and dipper stick to keep them running smoothly. If a machine breaks down, many men may be kept from work. This means loss of time and money. Now the ground is fairly level and is ready to be graded off. Powerful graders and scrapers take over the job. This Caterpillar tractor, called a bulldozer, weighs 18 tons and has a blade in front 11 feet wide. These tanks are similar to those used in warfare. They can go up an angle over 45 degrees. And here we have a sheep-foot roller which smooths the ground still further. In a large construction job, various types of work are carried on at the same time in different parts of the project. Men dig the trenches for the underground construction work, such as drain pipes, sewer pipes, and domestic water pipes. Storm drains are necessary to carry the surplus water off the roads in heavy rains. These concrete pipes are laid out in sections and are carefully joined. A crane hoists a huge section of iron pipe for the domestic water supply. Iron is used because it is stronger and can carry more pressure. The pipe must be painted white, otherwise the hot sun would make the iron too hot to work on. Tar is used to paint the joints of the pipe to keep out moisture. The men who work on the tar wagon wear dark glasses and paint their faces with a protective cream to keep them from being badly burned by the fumes from the hot tar. The men who work around the pipes must wear masks to prevent them from breathing the poison fumes from the paint. The joints are tested by an electrically connected brush which will show a spark if at any spot the pipe is not covered by the tar. The man marks a spot and it is quickly mended. Men must be aware at all times of the dangers connected with their work. Here the welders are working in a trench that is 12 feet deep. Arc welding is very hot work. It reaches a heat of 6,300 degrees Fahrenheit. The welders cannot stand the heat for very long and so alternate the work in short shifts. This large pipe runs through a bypass in the mountain to carry domestic water from the aqueduct high up in the mountains to the city reservoir. Smaller trenches are made to hold the cast iron service pipe for drinking water. Ropes make it easier to lower the heavy pipes. These smaller pipes lead out from the big iron pipe, part of the distributing system that brings the water from the reservoir to your home. An important part of this road building project is the construction of power lines, telegraph lines, and telephone lines. These are built underground and high above ground. Here, electricians carry on their work while balanced dangerously on ladders and poles. This lineman carries his tools on his belt. Every tool has its special place. Steel spikes on his boots dig firmly into the post. He climbs up easily and quickly and works as if he were in his own shop. He will pull the wires into position and install the fixtures for the electricity. Connections must be cleaned, soldered, and wrapped with rubber tape to ensure perfect insulation and long service in all kinds of weather. An imperfect connection would be dangerous to the electricians who mend the wires. It takes men of many trades to build a road, but when the noon whistle blows, they're all ready to stop for lunch. Men have to eat, and who deserves food and rest and a friendly argument more than these builders of the broad highway? studying the blueprint for a bridge. Plans are consulted frequently for each piece of construction work. These plans will help them to figure out the exact measurements and the best way to build the parts for a bridge. Here they are making a model of a span for a bridge. Now, the first step in making a bridge or a retaining wall is to erect a form of wood for the concrete. These carpenters are making sections of the forms for a retaining wall. They can be built more easily on the ground and later assembled high above ground. Many carpenters are required on a large project and may have steady work for many months on a single construction job. Now the men are putting the forms in place at the top of a retaining wall. They must be fitted together with close joints to prevent the concrete from leaking out. When the form is in place, a hose cleans out the chips and shavings. The smoother the forms, the smoother the finished concrete will be. This large retaining wall at the side of an underpass is ready for the concrete work. Each compartment of the truck contains the right amount of gravel and sand for one batch. The concrete for this wall will contain 1 part cement, 2 parts sand, and 3 parts graded rock. And up the batch goes in the machine mixer to be made into concrete in 90 seconds. Now the concrete pours out into a bucket that holds 1 cubic yard. The crane easily lifts the heavy bucket to the top of the retaining wall where the concrete is poured into the high frame. Teamwork is required at all times. The concrete is poured in 3-foot layers from the bottom to the top of the wall. This work is done by skilled and semi-skilled cement workers. Before the concrete sets, an electric vibrator is used to compact the concrete into a solid mass. Yes, riding the bucket looks risky, but it's quick and makes the work much easier. Many trips are required to fill the large wall. A finisher smooths off the top with a trowel. Later, the wooden forms will be removed, leaving a white concrete wall. Inspectors watch the work to see that everything is built according to the plans. The reflection of the sun in the mirror enables the inspector to see in the darkest corner. When the sun is not shining, he uses a flashlight. He is checking to be sure all the fastenings on the forms are secure. If the form should burst out and spoil the shape of the wall, the concrete would all have to be pulled out and the forms rebuilt. This would be costly. When the forms have been removed, the concrete wall stands strong and firm, ready to be cleaned and smoothed. Electricians erect the lampposts along the lower roadway and also along the road on the top of the retaining wall. A roll of burlap protects the post from the cable ropes as it is being hoisted. When the lamp post is in position, the cable is removed, then it's down the boom. The base of the lamp post is bolted into the foundation and cemented into place. Men pull the wires through the post and put a transformer in each pole to bring the electric current down to the proper voltage for the lamp. At the end of the wall is a huge underpass where steel workers are putting in place the steel reinforcing bars. Carrying these bars is heavy work, as each bar is 70 feet long and weighs 450 pounds. It takes strong men to carry these single steel bars. Most of these men are experienced steel workers. Overseers and inspectors see that the steel bars are placed the proper distance from the forms. Now, these bars are being placed unusually close together, which shows that this bridge is being built to carry heavy loads. The steel carries the load and is held in place by the concrete. Yes, indeed. These men are getting their iron. At the other side of the underpass, a pile driver is driving the piles into place for the false structure on which the concrete bridge will be built. This man is adjusting the huge hammer which will pound the pole into place. The cranes lift up the heavy hammer which falls on the pole and drives it into the ground until it is firm enough to carry a 20-ton load. Engineers can measure accurately the resistance of a pole to a definite weight. The operator of the pile driver operates his machine skillfully. In another part of this road building project, concrete workers are making curbs and gutters. Here, a concrete mixer on a truck, called a transit mix, is pouring concrete into the wooden forms. A combination curb and gutter is made at one time. Men smooth out the concrete and tamp it down. When the concrete is hard enough, the forms are removed. Next, men smooth the face of the curb and finish it off. Say, what's up? A crane over. Perhaps the swing of the bucket was too fast. Anybody hurt? Oh, too bad. Tom Clark, an expert crane driver. The men hurry to help him. They rush him to a hospital where he will receive first aid immediately. But the work must go on. Our crane is pulled into place and mechanics repair the damage. But let's return to our road. The curbs and gutters are in place. The ground is graded to a definite level to leave the required space for the concrete. When it has been smoothed and sprinkled, it is ready for the concrete. Then our mixer comes into action again. This time, a bucket runs out on a boom and pours the concrete on the grade. The spreaders who smooth out the concrete must be strong men, as this is heavy work. The next step, a mechanical spreader smooths and tamps it down. The second trip of the spreader finds the concrete much more level. When this machine has tamped it down fairly evenly, the finishing machine takes over the work. These machines have a system of rollers and trowels to smooth off the concrete. Many different types of machines are used in a road building project. These men are filling in the section joints with tar. Spaces are left to allow the concrete to expand in hot weather and to contract in the cold, thus preventing a break in the slab of concrete. Parts of the road are finished. The bridge, whose spans we saw on the blueprint in the beginning of our picture, is open to traffic. This highway will take its place among the great ones of the United States. The famous Columbia River Highway now seems a remarkable example of man's skill, taking us over mountains with fairyland views of the beautiful river. And now, from famous George Washington Bridge over the Hudson River in New York City, we glimpse one of the most modern and most complicated highway intersections in the world. A square acre of cement was used in the construction of this bridge. Cars travel so swiftly from the center of the city to the outskirts that it is almost like being carried on a magic carpet. Truly a 20th century miracle.